Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first part of triangles where we have seen what are triangles and its properties, different types of triangles and so on. In case if you haven't gone through that video till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to see two very important theorems, Apollonius theorem and angular bisector theorem. So let us begin with today's video. Before seeing the Apollonius theorem and angular bisector theorem, first let us see what is a median and angle bisector of a triangle. Suppose we have a triangle ABC with three vertices A, B and C such that from the vertex A, if we draw a line segment AD such that the point D divides the side BC into two equal halves, that is, D is the midpoint of the side BC. In that case, AD is said to be a median of the triangle ABC from the vertex A. In a similar way, if we draw a line segment BE from the vertex B such that the point E divides the side AC into equal halves, then BE is also a median of the triangle from the vertex B. In a similar way, if we draw a line segment CF from the vertex C such that F is the midpoint of the side AB, then CF is also a median of the triangle ABC from the vertex C. Now, all these medians meet at a point, and this point is called as the centroid of the triangle, which we generally denote by capital G. Well, we'd be knowing more about the centroid of a triangle in the next video when we'd be seeing geometric centers of triangles. But for the time being, let us simply know what is a median, which is simply a line segment from the vertex to the other side of the triangle, which divides the other side into two equal halves. Now, let us see what is an angle bisector of a triangle. Suppose again, if we have a triangle ABC such that angle A, angle B, and angle C are the three angles of this triangle, then if we draw a line from A such that this line divides the angle A into two equal halves, then this line is said to be the angle bisector for the angle A. In a similar way, if we draw a line which divides the angle B into two equal halves, then this line would be the angle bisector for angle B. And if we draw a line from the angle C such that this line divides the angle C into two equal halves, then this line would be termed as the angle bisector for angle C. Since these lines divides the internal angles of the triangle, they are termed as internal angle bisectors. In a similar way, the lines which divides the exterior angles of a triangle into two equal halves are said to be external angle bisectors. For example, if we consider the exterior angle C, then the line which divides this exterior angle C into two equal halves will be termed as external angle bisectors. In a similar way, we can have the external angle bisectors for angle A and for angle B as well. So, a median of a triangle from a vertex is a line segment which divides the opposite side into two equal halves, and an angle bisector of a triangle is a line which divides the angle into two equal halves. Now, let us see what is an Apollonius theorem. Apollonius theorem is a theorem which relates the length of a median of a triangle to the length of its sides. Suppose if we have a triangle ABC such that AD is a median from the vertex A on the opposite side BC. Since D is the midpoint of the side BC, the length of BD would be equal to the length of DC. Apollonius theorem states that twice of BD square plus AD square would be equal to AB square plus AC square. That is, the sum of the squares of any two sides of the triangle would be equal to twice the square on half the third side together with twice the square of the median bisecting the third side. This Apollonius theorem would be very much helpful whenever we need to find the length of any median of a triangle when the length of the sides are given. Here, AB is one side of the triangle, AC is the other side of the triangle, and BD can be written as half of BC. So, if we know the length of AB, the length of AC, and the length of BC, in that case, we'd be able to find the length of AD, that is the length of the median of the triangle. So, whenever we need to find the length of the median of the triangle, given the length of the sides of the triangle, we can directly use Apollonius theorem. Well, we can also prove this theorem simply by dropping a perpendicular from this vertex A on the opposite side BC and then using Pythagoras theorem and then simplifying it. But my suggestion would be to simply remember this theorem, which would be sufficient. Now, let us see what is an angular bisector theorem. The angular bisector theorem of a triangle states that the angular bisector of an angle bisects the opposite side in the ratio of the other two sides. That is, if AD is the angular bisector of angle A for this triangle ABC, then BD by DC would be equal to AB by AC. That is, this internal bisector of this angle A bisects the opposite side in the ratio of the other two sides. Since here we have considered the internal angle, this theorem is known as internal angle bisector theorem. Now, instead of this internal angle A, if we consider the external angle A, then also this theorem is valid. That is, the external bisector of an angle will also bisect the opposite side in the ratio of the other two sides. So, if AD is the external bisector for this angle A, then in this case also, BD by DC will be equal to AB by AC. And since this is the external angle, this is known as external angle bisector theorem. So, in a triangle, the angular bisector of an angle bisects the opposite side in the ratio of the other two sides, and this is known as angular bisector theorem. Now, let us see one question based on Apollonius theorem and angular bisector theorem. So, we have been given a triangle PQR where the length of PQ is 6 units, the length of PR is 8 units, and the length of QR is 7 units. Also, it has been given that PS is an angle bisector of angle P. So this PS is the angular bisector for angle P. So this angle will be equal to this angle. Also, PT is the median of triangle PQR. Since PT is the median, so this T would be the midpoint of the side QR. So the length of QT and the length of TR would be same. And we need to find the length of ST and the length of PT. Since T is the midpoint of the side QR and the length of the side QR is 7 units, so we can say that the length of QT and the length of TR would be half of 7, which would be 3.5 units. So QT length is 3.5 units and TR length is also 3.5 units. Since PS is the internal angle, so we can use internal angle bisector theorem. So we can write PQ upon PR to be equal to QS upon SR. And the length of PQ is 6 units and the length of PR is 8 units. So the ratio QS upon SR would be 3 upon 4. Since QS plus SR is equal to the length QR, which is 7 units, and QS is to SR is 3:4, so we can say that the length of QS would be 3 units and the length of SR would be 4 units. Now, the length of SR is 4 units and the length of TR is 3.5 units. So, ST can be written as SR minus TR, which would be 4 minus 3.5, which would be giving us 0.5 units. That is, the length of ST is 0.5 units. Now, we need to find the length of PT, which is the length of the median for this triangle. And we know the length of the other sides of the triangle, PQ, QR, and PR. So we can directly use Apollonius theorem, from which we can find the length of PT. So using Apollonius theorem, we can write twice of PT square plus QT square would be equal to PQ square plus PR square. Now, if we put the values, in that case, this would be twice of PT square. The length of QT is 3.5 units, so this would be 3.5 square equal to the length of PQ, which is 6, so this would be 6 square, and PR is 8, so this would be 8 square. Now, if we simplify this, in that case, PT square would be equal to 37.75. So the length of PT would be root of 37.75 units. So the length of ST is 0.5 units and the length of PT is under root of 37.75 units. So in this way, by using the angular bisector theorem and the Apollonius theorem, we can find such lengths. So that's it for today's video, in which we have seen two very important theorems, Apollonius theorem and angular bisector theorem. And in the next video, we are going to see the geometric centers of triangles like centroid, circumcenter, orthocenter, and so on. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.